So I hope you can see my screen well. So I will start by saying that Eurisy is a small non-for-profit organization. We are based in Paris and we are hosted within the European Space Agency's premises. We are an organization of space agencies. As you can see in this slide, our members are mostly European national space agencies and offices, national offices dealing with space affairs. And we have been mandated by our members to act as a community to bridge the gap between space and society. And we do so through an approach which is basically of raising awareness on the potential and on the benefits of satellite-based application for different professional communities. And we do so by stimulating the dialogue between the space community and all the relevant professional communities. And through the years, we built a network of a solid network of non-space professional communities and users that are early adopters of satellite-based application. We do act as well as a matchmaker, bringing in contact service providers with final users, and we do act as an advisor for decision and policymakers, bringing through a bottom-up approach the feedback on the bottlenecks, the obstacles in the uptake of the satellite-based solution to basically smooth the path for the adoption. In this sense, Eurisy works on different thematic areas that are selected according to the major, let's say, strategic priorities. Among those strategic thematic priorities, we can name future health, for which we produced recently a report on how space can contribute to trace the effects and to monitor the effect of the pandemic, or space for culture, space for cities, and the space for rural, for instance. And among these, there is, of course, a space for maritime. The objectives of our initiatives are mirroring basically the approach that we have in, let's say, working and we identify, indeed, we map the stakeholder of the sector, we do understand their needs, and we favor an interaction of with service provider. We do also gather cases of early adopters of satellite-based application to promote the benefits they have in the integration of those solutions within their workflow, and we do report back on this to the institutions. So we are here today to discuss a little bit about maritime spatial planning, and I will soon leave the floor to the different speakers. We do want to understand the needs of the sector, and this series of events that will see an end today with this last webinar has been co-organized in cooperation with ESA. And again, we discussed on previous days about different topics. Today, we wanted to have an overview on renewable energy, coastal protection, and coastal planning, port development. I do invite everybody, again, who has a question to write on the chat or on the dedicated section in the screen that you see. We will gather all the questions and we will ask it to the speakers at the very end of all the presentations. And well, you find us on all the different social media, and I invite all of you to visit our website and to contact us to tell us a little bit more about your activities. Having said this, I will give the floor, I will introduce and give the floor to Isabelle Dubois-Béchamp. So again, as it is the case for myself, you might know Isabelle by now. She is the head of the Member States Relation and Partnerships Office within the European Space Agencies, and she is coordinating at corporate level all the information on the agency's policies and actions toward the 22 member states. She's basically acting as the entry point of the member states to the agency. And as we know by now, the Member States Relation and Partnership Office is in charge for the, let's say, development and design of specific initiatives, among those the regional initiatives, within which we can find the Blue World Task Force. So Isabelle will tell us today a little bit more about the task force and the stakeholder consultations initiated and that gave, let's say, the input to this series of webinars. So Isabelle, I leave you the floor.
Thank you, Annalisa. Can you hear me?
Yep.
Okay, I will cut my camera because sometimes I have connection problems, so I will just turn off the webcam. Okay, so good afternoon. Thank you for being there. I will repeat a bit what I have said at the other webinars, so I'm sorry for the geeks that follow all webinars of Eurisy, but it will be a bit the same. Just for those who might not know what is ESA, so in short, we are an intergovernmental organization with 22 member states, and we are dealing with mainly all space areas, from Earth observation to launchers via telecommunication and human spaceflight. The budget in 2021 is some 6.5 billion euros, so not very much, because it's only something like 12 euro per European per year, approximately. And in the frame of our activities, we are supporting, of course, our member states. They are the one who fund the budget. Let's say 3/4 of the budget is coming from the member states, and 22% is coming from the European Union, and then there are other providers. So we have what's called regional approach, and the one that started relatively recently is the one that we call Blue Worlds and Blue Worlds Task Force. We are building on a certain number of activities on a specific mapping exercise that was done in 2019 to map ESA activities that have an impact or could have an impact on maritime activity at large. The task force itself was created end of 2019 with all interested member states representative, and we have 19 out of the 22 member states that are represented, plus one associated. And of course, with our ESA experts from the various programs that are concerned. And we discuss in this task force what are the needs of the maritime sector, what are the expectations, how space asset could answer to that, and how to better prepare the future programs. It's part of the thinking that we cannot develop program if we do not work with the one that will use those programs. And the maritime area is a very large one with many different actors, and today you will hear some of them that more or less all need space or will need more space in the future. And in the frame of the discussion, it was suggested that we should launch a survey to know better what are the needs of this sector. When I mentioned the regional approaches, it started with the Arctic in 2012 for the internal work and 2016 for a task force. And it led end 2019 to propose a demonstrator for an Arctic weather satellite that was adopted. We have some initial work on the Alps or Africa and some cooperation with Antarctic researchers. And the Blue Worlds one started 2018 with a request from Portugal. So I'm happy that Portugal is represented here. On the Atlantic, and it's particular for the Azores, so the Air Center is quite active there by definition. And in 2019 by Greece, asking that we look also at the Mediterranean area for the topics they are interested in. And the other member state that joined asked us also to look into the challenges, if they are different, for the Black Sea Danube area, for the Baltic, the North Sea, and the Arctic Ocean. So we look globally at what are the challenges faced and how space could answer. The survey itself, which is the ongoing, is that we want to collect the views of the maritime user to know what is needed, and also to potentially have define and develop new collaboration. The survey was disseminated end of January, in particular via our contact point in the member states that disseminated to their networks. But also we used our networks, Eurisy used its networks and others. So disseminated to a certain number of people we think would have an interest to answer. There are 28 questions, but many are multiple choice questions, so very easy to answer. So we think that some 10-15 minutes, not more, are needed to answer. There are some open questions. More or less 4 categories. One is some elements about the respondee, to know what type of respondee it is, even if it is anonymized for the survey itself. What are the maritime priority and the drivers and the challenges? So not considering space, but just what are the challenges that are faced by the one who is answering. Then some element of information of whether the respondee knows about space, uses space. If he doesn't, why? To have a kind of overview. And the last part is to know if there is an interest for a follow-up. So what would be expected from ESA or from National Space Agency as a follow-up, so that we could engage into discussion with potential users that would like to go further. The deadline is 28 February. We decided yesterday to extend it by another week. Yesterday we had some 130 already completed questionnaire, and some 400 in the making. Of course, the 400 in the making do not mean that they all answer the questionnaire, but we gave another weeks to give another opportunity for people to answer. So don't hesitate if you have questions also to ask questions. So this is all for me what I wanted to tell you as an introduction. And I will just stop sharing my screen. Normally, stop sharing. Thank you, Annalisa.
Thank you very much, Isabel, for your presentation. And indeed, we will share the link to the stakeholder consultation in the chat. So for all those who want to access it from here, it's available for everybody. So this said, I again invite all those who have questions to write it in the chat, and I will move to the next speaker, Miguel Baymora, the CEO of the Air Center. So Miguel is indeed the CEO of the Atlantic International Research Center, which is an organization developing scientific and technological applications in the Atlantic region. Miguel has been an entrepreneur in the European space sector, involved with management of international space programs with more than 37 years of experience. And he's the founder and CEO of several companies in the Deimos Group in several different countries, from Spain to Portugal, from United Kingdom to Romania and Italy. And he's also a full member of space international organizations such as the International Academy of Astronautics or the International Astronautical Federation, and the chairman of the Mission and Constellation Design Session at the EAC. So Miguel today will present to the audience how space assets can help to protect the Atlantic coasts. And without further delay, I will give the floor to Miguel.
Thank you very much, Annalisa. Let me share my screen. Let's see if I'm able to do that. Can you see my screen?
Yes, we can see your presentation.
Okay, thank you, Annalisa. I will, in my presentation, briefly introduce the Earth Center, the research infrastructure at the Earth Center, and I will present some examples of coastal protection on pollution, pollution control, coast water and air quality, natural disaster monitoring, and coast safety, fight against piracy and illegal vessel traffic. Well, as you said very well, the Earth Center is an international non-profit organization to develop scientific and technological applications. We have also focused to foster job creation and to monitor and contribute to reach United Nations Sustainable Development Goals. We use space, but not only space. We integrate space with climate, earth, ocean, energy, and data sciences. And we look very much to the collaboration over the Atlantic, south-north, north-south. We have different country members in the Earth Center. We have in Africa, well, South Africa, Nigeria, Angola, Namibia, Cape Verde. We have different countries in America. In Europe, it's Portugal, Spain, UK, Norway, and we're now in conversation with France, Germany, Denmark to become members of the Earth Center as well. And we are very close to ESA, the European Space Agency. In fact, we have an agreement with ESA, and we host a laboratory in our headquarters, which are located in Terceira Island in the Azores, where we develop Earth observation application for maritime application. Looking into coastal protection, we work with missions. We have different missions, and 3 of our missions are very close to in fact, dedicated to coastal protection. One of the missions is clean and productive bays and estuaries. Bays and estuaries are among the most productive areas on Earth, providing a wide range of valuable ecosystems. There we have to protect them, and we identify different services or products that we can do from satellite to help into this mission, which is coastal erosion monitoring, coastal pollution, water temperature, sea level rise, marine spatial planning. All those space applications are the ones that we identify that we are working towards this first mission. Another mission very close to coastal protection, in fact, in coastal protection, is resilience to coastal natural hazards. The frequency and severity of coastal hazards are increasing the last years. It's a result of the combined effect of climate change and human activities. We need to monitor those natural disasters, and we identify as needs climate change monitoring, mitigation of natural disasters, tsunamis, flooding, earthquakes, volcanoes, and extreme weather events, extreme weather forecasts. This is the list of activities we are working with. And the last line of our missions related to coastal protection is the improvement of the management of marine and coastal resources. Economic growth in the recent decades has been accomplished mainly through unsustainable exploitation of coastal resources. Then we need to stop this, and we need to work towards a sustainable use of coastal resources. And this is one of the missions. For that, we identify as a required products biodiversity monitoring, communication system to be able to track animals on the ocean, sargassum, coral, and seagrass monitoring, marine and coastal resources monitoring. All these needs are within our goals and the project we're going to develop. For that, we are setting up an infrastructure, international collaboration with all the countries in our organization. This is very much based on space, but in fact, it's more than that. We call it APOS. APOS stands for Atlantic Pole-to-Pole Observation System of Systems. Pole-to-pole, because we cannot understand the Atlantic regionally. The Atlantic is a unit, Arctic to Antarctic, and everything has influence everywhere. Then we have to take the ocean as a whole, a system of systems, because we are not only using space. You cannot solve all those challenges only with the space application. You need to combine data from atmospheric component like UAVs or high altitude platforms, like sea surface component like buoys, drifter vessels, but also water column. We need gliders, we need data to get combined with the satellite data. We have our control center in Terceira, is an island in the Azores, and what we generate is a set of data. This data, it's by big data science techniques, we make it available to all our partners. Our partners are governments, universities, but also companies, industries. We work with all types of stakeholders, and the real interesting thing are the products, and we made this available to all those players. That's that with artificial intelligence, mathematical models, we can deliver solutions for fisheries, for coastal erosion, for biodiversity. And we use those existing assets, but we identify that there are some gaps. we need more frequent data. There are some ocean phenomena that needs revisit time of the order of 3 hours. For this, we are designing the Atlantic Constellation. It's a constellation of 16 satellites to complement the Sentinels, the Copernicus Sentinels we're using very much. Is a highly sophisticated system in Europe, but we want to complement with this constellation of 16 satellites in collaboration with the countries of the Earth Center. And as I said, the important thing are the application. What are the application? Well, some examples. Coastal pollution control is one of the services. Oil spills is one of the most important, and the Prestige catastrophe was a service was very well appreciated and in Spain, in Portugal, because of this oil contamination. But it's not only oil. This is an example in this image. This is volcanic eruption in Canary Island. This is El Hierro, an island in the Canaries. There was a marine volcanic eruption creating a lot of debris. All this debris, which is volcanic ashes. Then with the satellite data and hydrodynamic models, we could detect which are the costs which will be affected, so that we can protect this cost and alert for tourists and other application. Discharge of wastewater. I mean, this is some organic discharge in the north of Africa, but we don't have to go to Africa. This is Malaga, and close to the Malaga port, we can see also organic matters in suspension. Also, air quality. This is the coast of Canary Island, highly affected by a storm of dust from the Sahara, which creates very bad atmospheric conditions. This is regarding pollution control, but also disaster monitoring. Disaster monitoring is one of the key space applications. This is an example of the Japan tsunami. That was satellite image taken by a medium resolution satellite of the whole region affected by the Japanese tsunami just a few hours after that happens. All this cost was the one affected. It was several hundred kilometers affected by that. Then you need a large view satellite to have a synoptic view of that. There are some examples. This is, for instance, a view of the Sendai region in Japan. This is before and after the tsunami. Before the tsunami, this is an agricultural valley, and in a few hours, water fall down up to 15 kilometers inland, creating a fjords. All this is detected with control detection algorithm. Then we can tell the relief teams what are the roads available, what are the rail tracks that they can use, but also we can identify which are the urban region most affected. And even if the terrestrial communication network is gone, you can use all these satellites because it does not require the terrestrial network. This is another example of the same image. This is the Fukushima nuclear power plant. You see that the difference before and after. Just a few hours after that, we could see that the nuclear power plant was completely flooded, and there will be a problem on the nuclear power plant. That's some years, more years ago. Go back to the Katrina. The Katrina was a good example also how satellite helps. Those are some satellite images of the New Orleans area. You go down to New Orleans, you could in a few hours tell all the relief team that this highway cannot be used. This region can be very well used, and you see which is the affected part of the New Orleans city. This is a very valuable data for the charters to be able to do the monitoring. Other type of application, natural parks in the coast. This is Maspalomas Natural Park, a beautiful dunes park in Canary Island. And you see that it is very much affected by pressure. There is the pressure of human construction. Those are touristic resorts. There is a pressure of coastal erosion, and it is satellite data which help us to protect natural park in coastal environments. Also, sea level rise. That's the Bora Bora Island, paradise resort in Bora Bora, which it's in danger because sea level rise, I mean, could be a big problem for that. We need to closely monitoring this type of resort because otherwise sea level rise will make this completely weightless. Also, coast safety. The use of satellite data combined with artificial intelligence can help us to be protected against pirates. This is the Indic Ocean. This is not the Atlantic. In the Indic Oceans, there are some piracy activities. But you have to distinguish between fishing boats or pirate boats. With artificial intelligence techniques and machine learning techniques, you can distinguish which is the behavior of a pirate or the behavior of a fishing boat. For instance, those were identified as 3 pirate boats just waiting a vessel to be hijacked. In addition, those services can give coast safety, but detecting pirates infrastructure. This is an infrastructure used for pirates, and those are the tracks. there are 100 tracks going to the coast, and we have to identify which is the one used by the piracy, and we can do that by satellite. Those tracks in Africa, which are not used, generate vegetation, generate chlorophyll, and give a signal in the near infrared. Then you can easily distinguish which track has been used and what has not been used. Additional application could be illegal vessel traffic. This is the Gibraltar region. In the Gibraltar region, there are, unfortunately, narco-traffic activities, illegal immigration. There are dense traffic. You cannot patrol every single vessel in this heavy traffic. For that, we use a combination of different satellite data. We combine radar SAR with optical images, with AIS vessel identification. We cross-check the image with the AIS, and what is not identified is suspicious of being narco-traffic or illegal vessel traffic. Then you only have to patrol those unidentified vessels, which helps very much the Navy to give control of all those illegal activities. Well, those are just examples of coastal protection that we have been working in the past. And in fact, as conclusion, we at Air Center has been already consolidated as an important international network for this technical and scientific collaboration in the Atlantic. Coastal protection is one of the key elements of the Air Center missions. 3 of our missions are directly pointed to coastal protection. We do that in a close collaboration with ESA, with the European Space Agency, at our ESA lab at Azores. The use of this Earth observation data provides this valuable tool combined with other sensors and combined with artificial intelligence algorithms. For this, we are really grateful, and if we could use more data, I mean, we are very grateful if the Copernicus European program will develop new systems with better spectral, better spatial resolution, with better revisit time, so that we can better serve to all those coastal protection services. Thank you very much for your attention.
Thank you very much, Miguel, for your very insightful presentation. You provided us and the audience with a lot of different examples on the challenges of the let's say coasts, not only of Portugal, let's say, so not only like in the Atlantic side, but and a lot of different examples of how satellite can indeed tackle those challenges. Again, the questions will be posed to the speakers after the end of our presentations. And now I will move to the next speaker, Eric Malta, project manager at the Center of Aquaculture Technology in Andalusia, in the south of Spain. So Eric is working for the independent non-for-profit foundation, which is Aqua, since 2017, and he's a marine ecologist, obtained a PhD in dynamics of seaweed bloom in relation to eutrophication, and since then he has been working in several European countries and abroad, doing fundamental and applied research on seaweed ecology, cultivation and application, and managing several projects applied in these specific areas. So Eric today will present how GIS mapping tools can support in coastal planning with some example again from the Atlantic coastal zone. So Eric, the floor is yours, and we look forward to your presentation.
Okay, can you see my presentation now?
Yes.
Okay, excellent. The only thing is I can't. Second, yeah. Okay, I will very shortly introduce Aqua, then continue with some examples of use of satellite imaging that I've used myself before moving to Aqua, but that can also be used for aquaculture applications. I will mention shortly the Eurosy project, in which Aqua is end user. And then the main part of my talk will be some examples from the Aqua and Omni Interact project. So, very briefly, Aqua is an Andalusian Aquaculture Technology Center. It's a non-profit private foundation. Our patronage, our board, consists of aquaculture farmers, feed companies, other accessory industry, universities, a few universities, and regional governmental institutions. We are located in the south of Spain, near to the city of Cádiz. The aims first are to develop applied research, technology, innovation, sustainability, and training within the aquaculture sector. So thereby we try to improve the competitivity of the Andalusian aquaculture companies. So we give support to these companies and we create a platform for collaboration between the research community and the private sector. So we act as an intermediate, but we also do research ourselves. So about more or less 50% of our budget consists of private research projects, of consultancy services to private companies, to aquaculture companies, and the other half comes from participation in national and international R&D projects. So, a short overview of our facilities. So we have cultivation facilities, we have various labs. As for water analysis, for food and feed analysis, we have a quite extensive and quite new seafood transformation section. So we experiment with different types of transformation, thereby also, for instance, reducing waste and spillage in the food chain. And we have our microbiology and pathology lab. So we work with fish, finfish, also some shellfish, and since I came to the center, also with algae and mainly with mackerel. So that's about Aqua. I want to give you some examples of what I have used in satellite imagery. I'm quite unfamiliar with the technology part behind it, and also even with the processing. I'm very much an end user using already processed images and data. So this is, for instance, one of the series I used when I was working in Portugal on macroalgae blooms, is using the AVHRR images to detect upwelling coming to the coastal zone. Upwelling is coming from the cold, it's cold water, so you can check sea surface water temperature. And when you see, as you can see, especially in the second and third image, where in the south of Portugal, you see more yellow-greenish spots here. That's where upwelling water reaches the coast. And that's important because upwelling comes from the deep, is usually nutrient-rich, and is therefore stimulating primary production. For aquaculture planning, this can be used, and this effect is done if you can map the duration, average duration of these upwelling events, and also their extension to what, especially in the Gulf of Cádiz, to where they tend to extend, how often they do they take place. You can use that to select sites, for instance, for bivalve cultivation or other types of aquaculture. Also, it's very useful if you are working on coastal eutrophication. So another example for which I've been using satellite pictures, this time just downloading them from Google Earth. I've been mapping macroalgae blooms, and I was also curious to see what past bloom events there have been. And these were very, very visible. You can see these bands parallel to the coast, these dark green bands, and also a bit more offshore, like up to 50 meters. Those are all macroalgae blooms. So I use this to check what years there have been blooms. Of course, then you depend on the amount of photos that is available and if they're in the right season. But especially in this area, this is the Algarve coast in Portugal, there were quite some photos available. So I could track years with and without blooms, and then try to backtrack those with other types of data. Water analysis data that we already had, or that were available on other platforms. So, okay. A project which is currently ongoing is the Eurysy project. We do not, as Aqua, participate in that as a partner, but we are an end user, so we are associated to that. Eurysy is improving and integrating the European ocean observing and forecasting system, for which it makes great use of all kinds of satellite data. And our task in this is that we participated as a kind of say person for aquaculture sector, together with other aquaculture representatives, and to detect what kind of data are very useful for the aquaculture. And if you remember, I think it was 2 years ago already, there were quite heavy storms in the Mediterranean that caused great damage to several aquaculture installations, both finfish and shellfish installations. Cages were dragged from their anchors and deposited on the coastline, some hundreds of kilometers from the place there where they were originally, or basically blown into the Mediterranean and sunk. So to prevent this, some forecasting systems would be highly useful, and the kind of data or models we would need is like probability maps with the timing of extreme events, so extreme wave action, extreme currents, also extreme temperatures, so certain high extreme temperatures, especially in the Mediterranean, important, that may kill your culture. So if you would know in advance, and a couple of days would be enough, that this is coming, you can take some measures. It's not always possible to do that, but in some cases it will be possible. By replacing the culture, by anchoring it more firmly, by harvesting already anticipated harvesting, those kind of measures can be taken. So there's also a very important, was an identification of the zone where many information is lacking. We have quite some information very near shore, and also quite some information offshore, but the zone, let's say the 25 to 50 meter depth zone, is very little known. And there were also some other aspects. So now I'm getting to the main part of my talk, is the Aqua Omni project. In here, we use actually the satellite data as the basis for our mapping. It's an interregional project between Spain and Portugal. It's a support for the management of wetlands on the southwest Iberian coast, where we're looking for interactions between aquaculture, sustainable aquaculture, and the environment in this South Portuguese and Southwest Andalusian region. So it's led by the Portuguese Institute for Atmosphere and Sea, and we are one of the partners. There is a website, it's mainly in Portuguese with some Spanish parts as well. Okay, so the objectives of the project were to improve the conservation status of coastal areas, to increase restored areas, and also increase their profitability. So the basis is that conservation of natural areas works much better if you can also get some profit out of it. You can create local support, etc. So we want to maintain and restore biodiversity and ecosystem services, promote, implement sustainable production methodologies, and contribute to more efficient management. So, and one of the main activities is the creation of a geographic information system for the saline and aquaculture production areas in the coastal zone to enable the sustainable management of these areas and to look for co-use models. The latter part is mainly taken up in Action 2. So, activity 1, the objective to obtain a zoning and regulatory instrument that will serve both entrepreneurs and administrations. So there was a clear need from those sectors. What can we do? Where can we do it? How can we plan it? And what other activities can we combine with those? So, and these were again divided in 2 actions. I will go briefly over this as time is running short. So the phases, first is the identification of the study areas. We divided the area in different sectors. Then very large phase was data search and acquisition from all kinds of state agencies, production sector, production co-ops, cooperatives, etc. The integration of data in the systems, preliminary cartography. So that's basically downloading the images and geo-referencing the images, and putting all the other layers of data on top of these images. So basically you start, this is the around city of San Fernando here close to Setacua. You start with an image and map like this, and you add all these layers, and you distinguish, oh, there's a few areas with the fishes in it that are suitable for aquaculture. Some areas are, for instance, military zones or purification plants that's not suitable, not allowed, or is a nature reserve for aquaculture is not allowed. So then so we have identified the areas where aquaculture could in principle take place. Then in the second phase with several users, several stakeholders, administration, companies, etc. We define criteria for co-use, criteria for sustainable use, what can and what cannot be done, and that we are still in the process of doing that. Thereby we can obtain a more complete map, which map the opportunities for aquaculture and other economic activities in the coastal zone. So very briefly, I hope to have given some examples of how we directly or indirectly use satellite images in aquaculture and in coastal zone planning of aquaculture activities. So thank you very much for your attention.
Thank you very much, Eric, for bringing us the perspective of user and how you indeed make actual use of the technologies and the final products you've been provided with in your daily, let's say, assessment of activities. So, again, I see that there's some questions. We will again pose it to the speakers at the end of the presentation. I will move to our next speaker, to Giovanni. Giovanni Siloslabini is an advisor of the DTA, which is the Technical Aerospace District in the Apulia region in Italy, and is the CEO of Planetech. So Giovanni started his career back in the early 80s at the Piano Spaziale Italiano, which is the today Italian Space Agency, and he worked there as representative of Italy towards ESA. He was director of the Center of Space Geodesy of the Italian Space Agency and the ESA facility for remote sensing, space geodesy and space robotics. For several years, he was also professor at Urban and Regional Planning course at the Venice University Institute of Architecture and cooperated with Nettuno Institute of the University everywhere. So today, Giovanni is the CEO of Planetech and the advisor of the Italian district of the Italian Technological Aerospace District, and the vice chairman of the European Association for Remote Sensing Companies, EARSC. Giovanni will present today the main space solutions developed for the maritime domain by the cluster of companies represented by the DTA. So Giovanni, the floor is yours.
Thank you very much for this introduction. I just try to adjust the window of my screen because you can see my screen anyway.
Yes.
Oh, a few words about the Pullian aerospace cluster. We are in a very southern region of Italy, in Apulia. We have more than 80 companies working in aeronautic and space. We have more than 100 million euros since 2014 in R&D activities, and we have a complete capability on the space value chain in our region. So I like start with this slide because I understand that managing the blue is managing a challenge, and managing a challenge means have data. And so in my brief presentation, what I would like to do is to give some views on which tools we can provide. First of all, to take a challenge, we have to manage a risk. So as you can see in this schematic model, there is a lot of information that comes from climate change variable, but also a lot of information about what is the entity of asset and the natural component of the landscape that are exposed to the challenge. For example, if we wanted to protect our coastal area from storm and flash floods, it's important to have a starting idea of what we have on the ground, and so have an idea about the assets, the population, the land use, the land cover. So one of the very interesting products bring to us from Copernicus and released just in yesterday is a complete land cover, land use map of the European 730,000 square kilometer of coast with about 60 different classes and with two status layers, one for 2012 and the latest for 2018, and also with the change layer. This will be a very useful instrument for mapping coastal area, but also to assess climate risk in coastal area, to define development and to monitor change. We are also partner of the Air Center and in the activities, for example, of the Climate Resilience Service, and Planetech Italia is the manager for this service, and we provide, for example, the component of coastal erosion risk assessment and monitoring of the sea level rise, and also the generation of flood extent maps. All these activities are I would go back to the, okay, so I see you. Essentially, the idea is to move from nice maps that we provided in the past to actionable information. So to produce analytics that support the decision. And I believe that the space component of this effort can be very useful in produce applications that are scalable in time and space. We are actively working in the evolution of these products toward the automatic generation of the products, and we believe that the effort made by ESA to interact with the potential user community is very useful in define a useful product for the end user, and also to make known the capability of the very important European effort in the Copernicus mission. Thank you.
Thank you very much, Giovanni, for the presentation and for showing us the very latest products that are available on European level. So in this sense, I would like to just pose you some questions. The first being for Isabel. This is mostly like about the result of the stakeholder consultation. So there is a question about the availability. Well, actually, if there will be a final an outcome of the consultation publicly available also for the audience, and when they should expect to have this outcome published.
Thanks, Annalisa. Yeah, indeed, we plan at least to have the analysis for the members of the Blue Earth Task Force, of course, so our member states, and we plan to make synthesis available for the public, let's say. I cannot tell you exactly when, because we will have to see how many questionnaires we have at the end and how long it is to analyze it, because there is a certain number of open questions. So the open questions take a bit more time to analyze than the closed ones. But indeed, yes, there will be a summary, at least, of the information that will be made on the internet or so. But I cannot yet tell you when. I would assume April, but we'll have to see.
So we just invite everybody to keep on following the ESA website, and it's likely there they will find all the information. Of course, we as Eurisy, we keep on supporting the outreach of those initiatives, so you are welcome. Then there is another question for Miguel, and he's asking some of the coastal protection activities, for example, protection against pirates, require a short-term response. The standard process, in example, downlink of data and ground processes, might take too much time to be deployed. Are you considering also an onboard processing and a kind of message system?
That's a very good question. That's the images that I saw was done with a constellation of 4 satellites. We give daily revisit, but for those type of a product, you need hour revisit. Then one thing you have to do is first go into Constellation. You have very, very short revisit time. And the other thing is what is proposed in this question, to do onboard processing with some algorithm on board, which can help on advancing the analysis, putting on board the artificial intelligence algorithm. This is which has been already done. There are some projects, one to detect extreme weather, doing onboard processing. This is an ongoing project on the European Union. And there is another ongoing project with some of our partners in Norway to do onboard processing of the texture of alga bloom, something that Eric discussed before, so that with a hyperspectral sensor, you have a quick onboard processing. You can send an alarm in case of alga bloom, harmful alga bloom for aquaculture. I think that's a good question, and what is proposed in this question is what we have to do. First, going through Constellation. Second, doing onboard processing.
Thank you very much. There is also another question for Eric, and is mostly indeed about the use of the pragmatic use of the information that you gather, and is asking what an aquaculture farmer can do to protect the site in case they know that there is a heavy storm coming.
Yes, well, it depends, of course, a lot on the type of aquaculture and how far offshore it is. It can go from anticipated harvesting. If you're close to harvest and you see a storm is coming, you can just harvest a few days or a week before the planned date. Another way is to reinforce the structure itself, add extra anchors. It depends a lot whether it's a cage, it's a long line installation, and how far from the shore it is. If it's really far away, then basically the only thing you can do is call your insurance company that's you're visualizing some losses. But especially for near shore installations, depending on the installation itself, those are the things. Reinforcing the structure, anticipate this harvesting, maybe even drag it away to close to shore, for instance. Those are kinds of measures you can take as an aquaculture farmer. But as I said, it all depends on the size and type of farm you have.
Well, I believe as a side comment that already have such an information available would give the possibility to act, to do something
Yes.
instead of just wait for the, let's say, event to happen,
Yes,
and being unable to do, anything else. So I don't know if there is any additional question. Not really. So I don't know if there is any other point or comments that we would like to discuss. So I see no further questions. In this case, we are slightly over time, but I will just wrapping up by saying that from what I can understand on your presentation, coastal areas are very much exposed to the effects of climate change and also human activities depending and deriving from the economic potential of those areas that is also increasing pretty much. This is creating and generating a series of challenges for the operators of those areas, from the mitigation of natural hazard, as we say, to the sea level increase, but also to the, let's say, optimization in the management of what is on the coastal areas. So the space based information can be like a quite of a important asset for provide the decision maker with informed and with data about this. It's also true that there's still some limitation, as we mentioned, about the resolution, for instance, that could indeed be improved. But in general terms, we see really like a great potential for space to contribute in the sector, and we look forward to hear more about the specific needs. So to all the users, please, take the survey, and to everybody else, we see you next time. I thank again all our speakers for your very great contribution today. And indeed, the presentation will be made available and everybody can have access in our website. Thank you very much. Thank you, Miguel, Joanna, Eric, Giovanni, for the contribution, and I hope to talk again to you soon.
Thank you. Bye.
Thank you.
Thank you. Bye-bye.
Bye.